Hello there, and welcome to The Sleepy Scientist. Tonight we turn our attention toward the warm, steady presence at the centre of our solar system. We drift gently toward the sun, not as a place of harsh brightness or intensity, but as a calm living star that moves in slow cycles of balance and release. And within that quiet rhythm, we'll explore solar flares, gentle bursts of energy that rise and fade like waves of light, guided by magnetic fields and time. Before we begin, allow yourself to settle comfortably. Let your shoulders soften, your hands rest easily, and your breathing slow without effort. There is nothing you need to focus on and nothing you need to hold in your mind. Whatever belonged to the day can fade into the background, becoming quieter with each calm breath you take. Solar flares may sound dramatic, but in the language of the universe, they are part of the sun's natural and steady behaviour. They are moments when magnetic energy rearranges itself, releasing warmth and light into space, then returning again to quiet stability. Even these bursts happen in patterns that are slow, predictable, and deeply connected to the peaceful physics of plasma and magnetism. As we continue, we'll explore the most relaxing facts about solar flares. We'll observe how they form, how they rise through the sun's atmosphere, and how they travel outward as soft waves of energy. These facts are not meant to excite or overwhelm. They are meant to slow your thoughts, soften your attention, and guide you gently toward rest. If you enjoy these calm journeys through the gentle side of science, you're always welcome to subscribe and return whenever you need quiet curiosity or peaceful sleep. But for now, allow your awareness to rest on the sun's warm glow and the slow magnetic motions that shape its surface. Let's begin. Solar flares begin with something that is surprisingly calm in concept, even if it sounds powerful in name. They start with magnetic fields on the sun, invisible structures that loop and curve through hot plasma like gently stretched threads. The sun is not a solid ball, but a living sphere of ionized gas. And within that glowing material, magnetic field lines can slowly twist, tangle, and store energy over time, sometimes for hours or days, building quietly without any sudden sign. The surface of the sun, known as the photosphere, is often where the first visible clues of solar flare activity appear. Darker regions called sunspots can form there, not because they're cold in an everyday sense, but because they're slightly cooler than the surrounding surface. Sunspots are created by concentrated magnetic fields that inhibit the normal flow of heat from below. When you imagine sunspots, it can help to think of them as calm, anchored places where magnetic energy gathers gently and patiently. Above the photosphere lies the sun's atmosphere, which is layered and delicate in its own way. The chromosphere sits above the surface like a thin veil, and above that is the corona, the sun's outer atmosphere, which extends millions of kilometers into space. Solar flares often release much of their energy into these upper layers, lighting them up in bursts of radiation that travel outward. Even in this there is a quiet order. The flare does not appear randomly. It follows magnetic structure, flowing along invisible pathways shaped long before the flare itself is seen. One of the most relaxing ways to understand a solar flare is as a sudden rearrangement toward balance. When magnetic field lines become tangled and stressed, they can eventually shift into a simpler configuration, releasing stored energy as they do so. This process is called magnetic reconnection. Though the word sounds technical, the idea is gentle. It is like a stretched elastic band quietly snapping into a new shape. Energy is released not as chaos, but as the sun finding a calmer arrangement for its magnetic field. The energy released in a solar flare can take many forms, including light across the electromagnetic spectrum. Some of it appears in visible light, but much of it is emitted as ultraviolet light and X-rays. These forms of light are not dangerous in space itself. They simply carry information about the temperature and energy in the flare region. In a calm sense, solar flares are like brief messages from the sun, telling us that its magnetic atmosphere has shifted and settled into a new pattern. Solar flares often occur near active regions, places on the Sun where magnetic fields are especially strong and complex. These active regions may contain multiple sunspots, swirling plasma, and arching loops of magnetism called coronal loops. Coronal loops are among the most soothing images of the Sun. They appear as graceful arcs of glowing material, tracing magnetic lines and slow curves. When a flare happens, these loops can brighten, expand, or reform, showing that even the Sun's most energetic moments are shaped into gentle geometry. Plasma in the Sun's atmosphere responds to magnetic fields the way iron filings respond to a magnet, except on a much larger and slower scale. Charged particles spiral along field lines, drifting through loops and arcs, and when a flare occurs, particles can be accelerated along these paths. The movement is not like a sharp explosion. It is more like a sudden rushing along an already existing road, where the direction was always present, waiting for energy to travel through it. Solar flares are often paired with changes that ripple outward into space, including waves and disturbances in the solar atmosphere. Sometimes, we observe something called a flare ribbon, bright regions that would appear in the chromosphere where energy is deposited. These ribbons can slowly spread as magnetic reconnection progresses. The spreading is calm and steady, showing the flare as a process rather than a single moment. Even though the energy is large, its evolution can be traced as a gradual unfolding. The Sun moves through cycles of activity that last about 11 years, shifting between quieter phases and more active phases. During the peak of the cycle, sunspots become more common, and solar flares can occur more frequently. During quieter phases, the Sun still shines steadily, with fewer disturbances. This cycle is soothing because it reminds us that the Sun is rhythmic. It is not random. Its energy release follows a long, slow pattern, like a heartbeat measured in years instead of seconds. Even though solar flares release tremendous energy, they do not change the Sun's overall stability. The Sun remains steady, shining calmly day after day, year after year, for billions of years. A flare is a localized event on a star that is vast beyond imagination. In perspective, it is like a brief shimmer on the surface of an ocean that remains calm and wide. The Sun continues its slow fusion in the core, its gentle pressure balance, and its steady outward glow, while solar flares come and go like small adjustments in the Sun's enormous magnetic atmosphere. Solar flares are often described as bursts of energy, but one of the most calming ways to view them is as moments of release that follow long periods of quiet preparation. Before a flare happens, magnetic fields on the Sun can spend hours, days, or even longer slowly building tension. This build-up is not something you would feel as drama. It is subtle and gradual, like gentle twisting in invisible threads. The flare itself is simply the moment when that stored energy finally finds a smoother, more stable arrangement. A solar flare does not begin in the Sun's core where fusion happens, but in the Sun's outer atmosphere where magnetism shapes the flow of plasma. This is soothing because it separates the flare from the idea of the Sun becoming unstable. The core continues calmly, producing light through steady nuclear fusion, while flares occur as surface and atmospheric events, like brief changes in weather rather than changes in the Sun's fundamental heartbeat. The Sun's atmosphere is structured in layers that each respond to energy differently. When a flare occurs, it can brighten the chromosphere and the corona, sometimes making these layers glow more intensely for a short time. The corona in particular is already an unusual and peaceful place. It is extremely hot yet very thin, and it stretches outward into space with soft looping structures that follow magnetic fields. In a flare, those loops can brighten or rearrange, offering a glimpse of the Sun's hidden magnetic architecture. Magnetic reconnection is the quiet physical process that often powers a solar flare. Field lines that were once stretched and tangled can break and reconnect into new shapes. This reconnection releases energy, heating plasma, and accelerating particles. Even though the energy is large, the process is guided by physics that seeks lower tension and greater balance. The flare can be seen as the Sun gently untangling itself, returning magnetic structures to a calmer state. Solar flares can be classified by their intensity using a scale based on X-ray brightness, with categories like A, B, C, M, and X. This scale might sound technical, but it is simply a way of measuring how much energy is released in certain wavelengths. Most flares are small and have little effect beyond the sun itself. This is comforting because it reminds us that solar flares are common and natural, and that most of them pass quietly without reaching into our daily lives. When a flare releases energy, it often sends out a burst of electromagnetic radiation that travels at the speed of light. This includes X-rays and ultraviolet light that reach Earth in about 8 minutes, the same travel time as ordinary sunlight. This speed can sound sudden, but the effect is usually subtle, like a brief change in the upper atmosphere rather than a dramatic event. It is a gentle reminder that we live in a solar system where light carries information continuously. Sometimes, a solar flare is associated with a coronal mass ejection, where plasma and magnetic fields are launched outward into space. But it is important to remember that not every flare produces a coronal mass ejection, and even when one occurs, it travels much more slowly than light. It can take 1 to 3 days to reach Earth. The calming perspective here is that the sun's energy release has multiple forms, and most of it disperses harmlessly into space, becoming part of the background flow of the solar wind. The solar wind itself is a constant gentle stream of charged particles flowing outward from the sun. It is always present, even when the sun looks calm. Solar flares can sometimes create temporary changes in this flow, but the solar wind remains a steady feature of our solar system. It shapes comet tails, interacts with planetary magnetic fields, and carries the sun's influence outward into deep space, acting like a continuous, quiet breath from the star at the center. On Earth, the most beautiful effect connected to solar activity is the aurora, the soft glowing lights that appear near polar regions. Auroras occur when charged particles interact with Earth's magnetic field and atmosphere, causing atoms to emit light. While auroras are more often linked to coronal mass ejections and strong solar wind changes, solar flares are part of the same family of solar magnetic behavior. The comforting part is that solar energy can create beauty as well as science, turning invisible particles into calm ribbons of light. Solar flare observations have become a peaceful part of modern astronomy because we monitor the sun continuously with satellites and instruments. These observations do not feel urgent in a sleep-friendly view. They feel like gentle listening. Scientists watch the sun's changing magnetic surface like one might watch slow waves on water. Through this steady monitoring, we learn that solar flares are not random bursts of chaos, but natural events in a star that is constantly finding balance between plasma flow and magnetic structure, releasing energy when it needs to, and then returning again to quiet, steady glow. Solar flares often begin in regions where the sun's magnetic fields are complex, layered, and quietly active beneath the surface. These active regions can look like clusters of sunspots, dark patches that mark where magnetism is strong enough to slow the normal flow of heat. What feels calming about this is that the sun is not suddenly creating energy in these places. It is simply gathering and organizing magnetic structure over time, like slow currents in a deep sea preparing for a gentle release. The sun's surface is in constant motion because it is made of plasma, a hot ionized gas where charged particles can move freely. Convection carries heat upward, and the surface churns in slow patterns that are larger than Earth. These motions twist magnetic field lines gradually, storing energy like a calm tightening of invisible threads. It is a steady process that can unfold quietly for long periods, making the flare feel less like an unexpected event and more like a natural continuation of slow motion. One of the most peaceful scientific details is that solar flares often trace out beautifully shaped structures called magnetic loops. These loops rise high into the corona, arching gracefully through space, filled with glowing plasma that follows magnetic pathways. Even when a flare happens, it tends to brighten these loops rather than destroy them. The sun's energy release reveals structure, showing us curves and arcs that already existed, like light gently turning on in a dim room to reveal a calm shape. The Sun's corona is an unusually serene environment, even though it is extremely hot. It is hot in temperature, but sparse in density, meaning there are fewer particles than in the lower layers. In the corona, plasma is thin and almost ghost-like, and magnetic fields guide it into smooth formations. Solar flares deposit energy into this region, heating plasma further and making it glow brightly for a time. Yet because the corona is already shaped by magnetic elegance, the flare often looks like soft brightening rather than violent change. When energy is released during a solar flare, part of it goes into heating plasma, which can then expand and flow along magnetic loops. This flow is not like a storm with chaotic winds, it is more like warm material drifting along curved paths, guided gently by magnetism. In many flare observations, you can see hot plasma filling loops like a slow tide filling a quiet bay, emphasizing motion that is guided, graceful, and shaped rather than random. Solar flares can also create waves that travel through the Sun's atmosphere, sometimes called magnetohydrodynamic waves. These waves are like ripples in a plasma ocean guided by magnetic fields. They carry energy outward in slow, graceful patterns, reminding us that even energetic events on the Sun can produce calm, wave-like motion, similar to the way a gentle disturbance on water becomes expanding circles rather than chaos. The classification of flares into C, M, and X categories is based on how much X-ray energy is detected near Earth. This measurement is simply a way of describing brightness in a specific wavelength band. Most flares are relatively small, and even larger ones are localized events on a star that is unimaginably large. The calming perspective is scale. Even a powerful flare is a small region compared to the Sun's vast surface, and the Sun remains steady and unchanged overall, continuing its slow, shining rhythm. Solar flares are part of the Sun's long cycle of magnetic activity, which rises and falls over about 11 years. During solar maximum, flares are more frequent. During solar minimum, they become less common. This cycle is soothing because it gives solar activity a predictable rhythm. The Sun is not random or unstable. It follows a long, steady pattern, like a slow tide of magnetism rising and falling over time. Even when a flare is intense, the energy it releases spreads outward into space and dissipates. Space is vast and acts like an endless calm reservoir where energy can travel without building up. Radiation moves outward, plasma can disperse, and particles drift into the solar wind. The universe's scale makes even strong events feel gentle over distance. Energy is released, then carried away, leaving the Sun ready to return to its quiet equilibrium. Solar flares also help us understand the Sun as a magnetic star, not just a bright sphere of heat. Magnetism is a quiet force, invisible yet guiding, shaping plasma into loops, arches, and patterns. A solar flare is one way magnetism expresses itself, releasing stored energy when the system needs to shift into a simpler arrangement. In this sense, solar flares are not interruptions. They are the Sun's way of gently adjusting its magnetic structure, maintaining balance in a slow and steady cosmic rhythm that continues calmly day after day. Solar flares are often described with energetic terms, but at their core they are about balance, returning to a system that has been slowly building tension. The Sun's magnetic field is constantly being shaped by the slow movement of plasma beneath and across the surface. Over time, the field lines can become stretched and twisted, quietly storing energy the way a gently tightened spring holds potential motion. A flare is the moment when the field finds a simpler shape, releasing energy as it relaxes into a calmer configuration. The Sun rotates, but it does not rotate like a solid object. Different latitudes spin at different speeds in a pattern called differential rotation. This slow, steady difference in rotation stretches magnetic field lines over time. It is a calm and gradual process, but it can create complexity in the Sun's magnetism, allowing energy to build up. The soothing part is that the Sun's rotation is steady and predictable, and the magnetic complexity that leads to flares grows patiently rather than suddenly. Sunspots where many flares originate are regions where magnetic fields rise through the surface and concentrate. These strong fields can suppress convection, making the spot cooler and darker than the surrounding area. Yet even in these darker patches, there is nothing harsh or threatening. They are simply places where magnetism is prominent, like calm anchors in a glowing ocean. When flares happen nearby, they are often the result of magnetic structures interacting above these anchored regions. Above active regions, the Sun's corona can form loop systems that extend high into space. These loops often appear as delicate arcs of glowing plasma, tracing magnetic pathways that are invisible but orderly. A flare can brighten these loops, making the structure more visible. This is one of the most calming visuals in solar science, because it shows energy release as illumination and reshaping rather than destruction, turning magnetic geometry into a gentle display of light. When magnetic reconnection happens, energy is converted into heat and motion for charged particles. Some particles are accelerated and travel along magnetic field lines, reaching denser layers of the Sun's atmosphere where they deposit energy. This can produce bright patches called flare kernels or ribbons in the chromosphere. These bright regions can expand slowly as reconnection progresses, giving the flare a sense of unfolding rather than a single instant, like a gradual spreading of warm light across a surface. Solar flares can emit energy across many wavelengths, from radio waves to gamma rays, but most of the most noticeable energy in space weather monitoring comes from X-rays and ultraviolet light. These wavelengths help scientists understand the flare's temperature and intensity. The calming perspective is that this emission is simply light, carrying information outward. It does not change the Sun's long-term stability. It is part of the Sun's natural behavior as a magnetic star. The Sun's atmosphere responds to flare energy in ways that resemble gentle fluid motion. Heated plasma can rise into loops, flow along curved magnetic arcs, and gradually cool. This cooling process can take minutes or hours, during which the loop systems slowly fade back to quieter brightness levels. This slow cooling is restful in concept because it shows that flare activity does not remain intense. It rises, peaks, and then gently returns to calm. Sometimes a flare can trigger oscillations in coronal loops, like gentle vibrations along magnetic structures. These oscillations are similar to waves traveling along a stretched string, except the string is magnetic field and the medium is plasma. The waves can travel, reflect, and gradually fade, spreading their energy smoothly rather than abruptly. This wave-like behavior reminds us that even energetic processes in space can manifest as soft rhythms. Solar flares are common on other stars as well, especially younger or more magnetically active ones. This makes solar flares feel less like unusual events and more like a natural feature of magnetic stars. Our Sun is relatively stable compared to many active stars, and most of its flares are modest. This is comforting because it places our star on the calmer end of a broader range of stellar behavior, reminding us that the Sun's energy release is part of a universal, steady pattern. Even the strongest solar flares do not significantly alter the Sun's total energy output. The Sun shines steadily because its luminosity is set by fusion in its core, a process that changes very slowly. A flare is a surface and atmospheric event localized and brief. This means the Sun remains the same steady source of warmth and light for Earth, continuing its calm existence while occasional flares appear as small, temporary adjustments in its magnetic atmosphere. Solar flares often feel dramatic only because they involve bright light and sudden increases in energy, but the quiet reality is that they are part of the Sun's normal way of easing magnetic stress. The Sun's surface and atmosphere are constantly moving, constantly reshaping magnetism in small ways. A flare is one moment when the system releases stored energy efficiently, allowing the magnetic field to settle into a simpler, more stable arrangement. In this sense, a solar flare is not chaos. It is the Sun gently restoring balance. The energy stored before a flare builds gradually in magnetic fields that arch above sunspot regions, These fields can become twisted as the plasma beneath them moves, like slow currents beneath floating ribbons. The twisting happens patiently, without warning sounds or visible disturbances to the naked eye. It is a quiet preparation. The flare itself is simply the brief moment when the stored energy finds its way outward as heat, light and motion along magnetic pathways. A calming detail is that solar flares tend to be confined by magnetism. The sun's magnetic field acts like a structure that guides plasma and energy. Instead of spreading in all directions randomly, flare energy often flows along loops and arcs. This guidance makes the flare look organized, with bright structures that follow gentle curves. Even at high temperatures, the motion remains shaped and patterned, as though the sun is drawing in light with magnetic lines. The chromosphere, the sun's lower atmosphere, is often where flares create some of their most beautiful and gentle signatures. During a flare, bright ribbons can appear on either side of a magnetic boundary. These ribbons can slowly expand outward as reconnection continues. The movement is gradual, like a slow opening of light across the surface, giving the flare an unfolding quality rather than a single, sharp moment. The corona, the sun's outer atmosphere, is where flare loops can become vividly visible. The corona is extremely hot but very thin, and its plasma is guided almost completely by magnetic fields. When a flare occurs, loops brighten as hot plasma fills them, then slowly cool and fade. This cooling and fading is soothing to imagine because it shows that flare energy does not remain intense. It naturally disperses and returns to calm. Solar flares can cause the sun's atmosphere to emit radio waves as well as X-rays and ultraviolet light. These radio emissions can be detected by instruments and help scientists understand the movement of charged particles. It is calming to realize that the sun is constantly communicating through gentle emissions across the spectrum, not as noise, but as signals that carry information about its magnetic and plasma environment. Not every flare leads to material being thrown into space. Some flares are confined, meaning they release energy primarily as radiation and heating within the sun's atmosphere, without launching a large cloud of plasma outward. This is a comforting detail because it shows that many flares remain contained and localized, like quiet internal adjustments rather than outward disturbances. When flares do accelerate particles, those particles often travel along magnetic field lines and may eventually interact with the solar wind. The solar wind itself is a steady, continuous stream of charged particles flowing outward from the sun. It is always present, like the sun's constant breathing into space. Flares can briefly add energy to this flow, but the overall wind remains a stable background feature of the solar system. Solar flares are part of a larger pattern of solar magnetism that also includes prominences, filaments, and coronal holes. Prominences are graceful arcs of cooler plasma suspended in the corona by magnetic fields, sometimes lingering for days or weeks. These features remind us that the sun's atmosphere is full of slow, elegant structures shaped by magnetism. Flares occur within this same environment, and they often interact with these structures without destroying the overall calm architecture. Perhaps the most restful truth is that solar flares do not make the sun unstable. The sun remains in a steady balance of pressure and gravity, powered by fusion deep in its core. Flares are surface-level energy releases, brief and localized. The sun continues shining with calm consistency, and flares become like small flashes of adjustment on the surface of a star that remain steady and patient across billions of years. Solar flares become most calming when you see them as part of the sun's quiet routine, not as rare disruptions. The sun is a living plasmasphere, always moving, always circulating, always reshaping its magnetic field in small ways. Most of these changes remain gentle and invisible from far away. A flare is simply one moment when the sun releases stored magnetic energy efficiently, then returns to steady glow as the magnetic field settles into a smoother pattern. The build-up to a solar flare often happens when magnetic field lines above an active region become twisted and sheared by slow surface motion. This shearing is not violent. It is patient, like two slow currents sliding past each other. Over time, energy accumulates in the magnetic structure like tension held quietly in a stretched thread. The sun does not rush, it allows the stress to grow gradually, and when the moment arrives for release, it happens quickly but still along structured, guided pathways. A comforting detail is that solar flares often follow a recognizable sequence. First comes a slow rise, then a bright peak, and then a long, gentle decay. The decay phase can last much longer than the peak. During this time, the heated plasma begins to cool and settle. This is soothing because the flare does not remain intense. It naturally fades, returning the sun's atmosphere to a calmer state, like warmth dispersing slowly after a brief burst of light. Solar flares can create a kind of temporary heating event in the corona, where plasma temperatures can rise extremely high. But the corona is already a place where high temperatures exist alongside low density. This makes it feel less like a furnace and more like a thin, glowing mist shaped by magnetism. When a flare heats part of the corona, it is like a local brightening in a wide, delicate atmosphere, revealing loops and structures that were already there, waiting quietly to be illuminated. After reconnection releases energy, hot plasma can fill coronal loops, making them shine strongly in ultraviolet and X-ray wavelengths. Over time, these loops cool through radiation and conduction, and the brightness fades. The cooling is gradual and smooth, creating a sense of slow settling. It is as though the sun exhales energy, then gently reabsorbs calm as the loops return to their quieter glow. Some flares are associated with something called a flare arcade, where a series of loops forms after reconnection. These arcades can appear as a row of glowing arches, standing like gentle bridges above the solar surface. They often develop over time, becoming visible as the flare unfolds. The structure is peaceful because it shows that flare energy release builds form and geometry rather than destroying it, turning magnetism into visible calm architecture. Solar flares are detected and studied through instruments that watch the sun continuously, like calm observers. Satellites such as those monitoring solar activity measure changes in brightness, temperature, and magnetic structure. This constant observation is not frantic. It is patient and steady, matching the sun's own rhythm. The science of solar flares is built on quiet monitoring, long-term data, and slow understanding, which fits naturally into a soothing view of the sun. Even though flare radiation reaches Earth quickly, its effects on the ground are usually minimal because Earth's atmosphere absorbs most high-energy radiation. The upper atmosphere may respond with small changes, such as temporary disturbances in radio communication or subtle heating in the ionosphere. These responses are gentle and often unnoticed in daily life. This is comforting because it shows that Earth is naturally protected and that most solar flare energy becomes part of the quiet interaction between the sun and the upper layers of our atmosphere. Solar flares are closely connected to the sun's magnetic cycle, which changes slowly over years. The cycle brings periods of more frequent flares and periods of fewer flares. This long rhythm is calming because it means solar activity comes in waves, like seasons of magnetism. Even at solar maximum, flares are still small compared to the sun's overall stability, and at solar minimum, the sun remains bright and calm, shining steadily. Perhaps the most peaceful way to end this set of thoughts is to remember that solar flares are not separate from the sun. They are expressions of the same quiet processes that keep the sun alive and structured. The sun's magnetism rises, twists, relaxes, and reshapes itself continuously. A flare is simply the moment when that reshaping becomes visible in light and heat, then fades back into gentle stability, leaving the sun's surface and atmosphere ready to continue their slow, patient dance. Solar flares can feel most relaxing when you imagine them as the sun's way of gently smoothing out its own magnetic patterns. The sun is constantly moving beneath its surface, sending heat upward through convection and letting plasma drift across its glowing face. These motions slowly twist magnetic field lines, storing energy quietly like tension held in a soft elastic thread. When a flare happens, it is not the sun becoming unstable. It is the sun releasing that tension in a controlled way and then settling back into a calmer arrangement. The sun's magnetic field is created by a process called the solar dynamo, a slow system that arises from the sun's rotation and the movement of plasma in its interior. This dynamo does not work quickly. It operates steadily over time, producing large-scale magnetic patterns that shift gradually through the solar cycle. Solar flares are small expressions of this larger magnetic behavior, like brief highlights in a much longer rhythm that continues patiently year after year. A solar flare often begins near magnetic boundaries on the sun, where field lines of opposite direction are pressed close together. In these regions, magnetic reconnection becomes possible, allowing field lines to break and reconnect into new shapes. The calming way to see this is a simplification. A complex, stressed configuration transforms into a smoother one. Energy is released as heat and light, but the underlying purpose is quiet. It is the sun reorganizing itself into a less strained state. During a flare, plasma can be heated to extremely high temperatures, but the corona remains thin and spacious. This makes the event feel less like a dense explosion and more like a brightening in a delicate atmosphere. Heated plasma flows along magnetic loops, filling them like warm liquid moving through a curved channel. The motion is guided, shaped, and graceful, reminding you that even energetic processes in the sun follow structure. Solar flares often reveal the sun's magnetic loops more clearly because they brighten in ultraviolet and X-ray light. These loops are some of the most soothing shapes in solar science. They arc gently from one foot point to another, rising high above the surface in elegant curves. When flare energy fills them, they glow like soft bridges of light, then gradually fade as the plasma cools, returning the corona to a quieter brightness. A calming detail is that the flare's brightest moment is usually brief compared to its slow decline. After the peak, the energy disperses, and the sun's atmosphere begins cooling and settling. This decay phase can last much longer than the initial burst. It feels like a slow exhale, where warmth spreads outward and then gradually blends back into the sun's steady background glow. Solar flares can also be accompanied by gentle wave-like motions in the corona, sometimes observed as ripples or disturbances traveling through the sun's atmosphere. These waves are guided by magnetic fields and plasma properties, and they often fade gradually as energy spreads out. In a sleep-friendly view, these waves can be imagined as soft pulses moving through a glowing ocean, traveling calmly and then disappearing into the larger stillness. Another quiet part of flare science is the idea that flares come in a wide range of sizes. Many are small, modest events that release energy without producing major disturbances beyond the sun. These small flares are part of the sun's daily life, tiny adjustments happening frequently, keeping the magnetic environment in balance. They remind us that the sun's activity is mostly gentle, made up of countless small releases rather than constant dramatic eruptions. Even when a flare does send energy outward, space itself absorbs it into its vastness. The solar wind carries charged particles away, and electromagnetic radiation moves outward at the speed of light, spreading into the empty quiet of the solar system. Distance softens everything. What begins as a bright burst near the sun becomes a gentle fading signal as it travels outward, blending into the background flow of the universe. Perhaps the most restful thing to remember is that solar flares do not change the sun's long-term character. The sun remains a stable star, shining steadily through billions of years. Flares are brief atmospheric adjustments, like small changes on the surface of something enormous and calm. After each flare, the magnetic field settles, the loops fade, and the sun continues its patient rhythm, glowing steadily at the center of our solar system. Solar flares become easier to rest with when you imagine them as the sun's gentle way of letting go. The sun carries magnetic structures like invisible arches above its surface, and those structures are shaped slowly by the steady motion of plasma underneath. Over time, the magnetic field can become twisted, storing energy quietly. A flare is the moment that stored energy is released, not as uncontrolled chaos, but as a natural step toward a more comfortable magnetic arrangement. A comforting scientific detail is that solar flares usually happen in regions where the magnetic field is strongest and most complex, often near groups of sunspots. Sunspots themselves are calm features, darker patches caused by magnetism holding back heat flow. They are not holes or damage. They're simply places where the sun's magnetic field rises strongly through the surface, anchoring loops that extend upward into the corona like gentle bridges of magnetism. The sun's atmosphere responds to flare energy in a way that feels like slow, guided motion rather than sudden turbulence. Plasma heated by the flare can rise into magnetic loops, filling them gradually and making them glow brightly in ultraviolet light. These glowing loops are some of the most peaceful visuals in astronomy because they show energy travelling along smooth arcs, revealing the sun's hidden structure as a quiet geometry of light. The flare's peak brightness is often brief, but its aftermath can last much longer as the heated plasma cools. Cooling happens through radiation and conduction, slowly reducing temperature until the loop returns to its quieter state. This long fading period feels soothing, like the slow settling of warmth after a brief bright moment, reminding you that the sun naturally returns to calm after releasing energy. Some flares create bright ribbons on the sun's surface seen in the chromosphere. These ribbons appear where energetic particles and heat flow down along magnetic field lines, depositing energy into denser layers. The ribbons can slowly separate and move outward over time as reconnection continues. This motion is not fast or sharp. It is gradual and smooth, like light gently spreading across a surface, emphasizing that flares unfold as processes rather than sudden flashes. Solar flares can sometimes be linked with coronal mass ejections, but it is peaceful to remember that the two are not always paired. Many flares are confined, releasing their energy mostly as light and heat without launching large amounts of material outward. Even when an ejection occurs, it travels through space over days, not moments, giving the entire system a slower, more gradual quality than the word eruption might suggest. When solar flare radiation reaches Earth, it interacts mainly with the upper atmosphere, especially the ionosphere. These interactions can change how radio waves travel or cause slight heating in high-altitude layers, but Earth's lower atmosphere remains calm and protected. This is comforting because it shows that the sun can express its energy while Earth remains safe, with most effects taking place in quiet layers far above where we live. Solar flares also remind us that the sun is not silent. Even though we cannot hear it, it constantly sends signals through light across the electromagnetic spectrum. During a flare, the sun briefly becomes brighter in X-rays and ultraviolet wavelengths, and instruments detect these changes as gentle variations in measured light. In this way, the sun communicates its magnetic shifts not through sound, but through soft patterns of radiation that travel outward like silent messages. The sun's magnetic cycle shapes flare frequency in a slow rhythm that lasts about 11 years. During solar maximum, flares and sunspots become more common. During solar minimum, the sun appears calmer with fewer active regions. This predictable cycle feels soothing because it gives solar activity a long, steady timing, like a heartbeat measured in years. The sun's behavior is not random. It follows patterns that rise and fall gently over time. Perhaps the most restful thought is that solar flares are small compared to the sun's overall stability. They are localized events in the atmosphere of a star that is vast, steady, and balanced. The sun continues shining day after day, holding itself in equilibrium through the slow, steady fusion in its core. Flares come and go like brief sparks of adjustment, and after each one, the sun settles back into calm magnetism and gentle glow, continuing its quiet presence at the center of our solar system. Solar flares can feel surprisingly calm when you think of them as moments of release rather than moments of danger. The sun is constantly holding magnetic energy in its atmosphere, quietly storing it as plasma moves and field lines twist over time. A flare happens when that energy is released efficiently, allowing magnetic structures to relax into a simpler shape. In that sense, the flare is like the sun taking a long, quiet breath out, letting go of stored tension and returning to a smoother balance. One of the most soothing details is that the sun prepares for a flare slowly. Magnetic field lines do not become stressed in an instant. They're shaped by gradual surface motions, like large-scale flows that shift and stretch over hours or days. This patient build-up means that a flare is not random chaos, but the natural result of slow change reaching a point where release becomes the easiest path forward. The sun's surface is covered in patterns of motion called granulation, created by convection bringing heat upward. These granules are like slowly bubbling cells, rising and sinking in a steady pattern. On larger scales, plasma flows can carry magnetic fields across the surface, moving them gently like leaves drifting on slow water. Over time, these flows can bring magnetic regions closer together, allowing complexity to build in a quiet, steady way that eventually supports flare activity. In many flares, magnetic reconnection happens high in the corona, where plasma is thin and space is wide. This makes the flare feel less like a dense event and more like a brightening in an airy atmosphere. The corona's thinness is calming because it means there is room for energy to spread out quickly without creating harsh pressure. The flare becomes a light-based event, visible mostly as glowing loops and bright patches rather than as anything that looks heavy or crowded. After reconnection, newly formed magnetic loops often appear as glowing arcs called post-flare loops. These loops can form a kind of arcade structure, lined up like quiet bridges above the sun's surface. They fill with hot plasma and shine brightly, then slowly cool and fade. This slow fading is soothing because it shows the sun gently settling after the release, returning its atmosphere to calm rather than staying in an intense state. Solar flares also illustrate that the sun's magnetism is constantly rearranging itself into patterns that favor stability. The sun is not trying to build tension forever. It naturally seeks lower stress configurations. Flares are simply moments when the magnetic field finds a better arrangement quickly, releasing energy that had been stored. This idea of nature seeking comfort and balance can feel deeply calming when you let it sink in. Some flares produce bursts of energetic particles that travel outward into space, but their motion is still guided by magnetic structure. Charged particles spiral along field lines, moving through space like beads traveling along invisible threads. Even when particles are accelerated, they do not fly randomly. Their paths are shaped, directed, and ordered by the very magnetic environment that created the flare, reinforcing the sense of structure within the sun's energy release. The sun's energy output as a whole remains steady despite flares. The light that warms Earth is produced by fusion in the sun's core, a process that changes very slowly over billions of years. A flare is small compared to the sun's total luminosity, more like a brief flicker on the surface of a steady lamp that continues shining without interruption. This scale difference is comforting because it reminds you that the sun's stability is far greater than any single flare. Solar flares can be studied through gentle, continuous monitoring by spacecraft and telescopes. Instruments record the sun's brightness in different wavelengths, mapping how flares rise and fade. This monitoring is calm and patient, matching the sun's rhythm. Scientists do not watch flares the way one watches a sudden emergency. They watch them the way one watches patterns, learning about magnetism, plasma, and energy release through steady observation over time. Perhaps the most restful thought is that solar flares are part of the sun's quiet, repeating nature. They happen, they brighten, and then they fade. The sun does not hold on to that moment. It releases energy, settles, and continues glowing steadily. In the broad view of time, flares are brief sparks within a star that remains balanced, warm, and constant, quietly shining at the center of our lives while its magnetic atmosphere continues its slow, graceful movement. Solar flares feel most peaceful when you remember that they are not the sun becoming unstable, but the sun becoming comfortable again. Magnetic fields on the sun can store energy as they twist and stretch, shaped slowly by surface motion and differential rotation. When a flare occurs, that stored energy is released, allowing the magnetic field to relax into a simpler configuration. In that sense, a flare is less like an interruption and more like a gentle correction, a small moment of rearrangement in a star that remains steady and balanced overall. One calming detail is that solar flares are often localized events, confined to relatively small regions compared to the Sun's immense size. The Sun is so vast that even a large flare is only a small patch of activity on its surface and atmosphere. This perspective is soothing because it turns something that sounds huge into something more contained. The Sun continues shining with the same steady output, while a flare rises and fades in a limited area like a brief shimmer on a wide ocean. Solar flares highlight the quiet power of magnetism, a force that shapes plasma without being seen. In the corona, magnetic field lines guide charged particles into looping arcs and graceful structures. When a flare happens, these loops may brighten, expand, or reform, revealing the Sun's hidden geometry. This makes the flare feel like a moment of illumination, where energy briefly brings the Sun's magnetic architecture into view, then allows it to fade back into gentle background glow. After the flare's peak, the atmosphere begins a slow process of cooling and settling. Hot plasma in loops radiates energy away, gradually lowering in temperature until it blends into the surrounding corona. This long decay phase is one of the calmest parts of flare behavior. It feels like the Sun gently exhaling heat into space, letting brightness soften and return to its normal steady state without hurry. The Sun's magnetic cycle provides a slow rhythm behind flare activity. Over about 11 years, the Sun moves between quieter and more active phases, and flare frequency rises and falls with that cycle. This long timing is soothing because it shows that flares are not random surprises. They're part of a predictable pattern of magnetic change, like a slow tide of activity that ebbs and flows over years rather than moments. Sometimes solar flares are accompanied by coronal mass ejections, but it is calming to remember that these are separate events that do not always happen together. Many flares are confined, releasing energy mostly as light and heat within the Sun's atmosphere. Even when a coronal mass ejection occurs, it travels slowly through space, taking days to move outward. The scale and pace of space itself makes even large events feel gradual rather than immediate. Solar flare radiation reaches Earth quickly, but Earth's atmosphere absorbs much of the high-energy light, protecting the surface. The ionosphere may respond with subtle shifts, and radio signals may travel differently for a short time, but life on the ground remains undisturbed. This quiet protection is comforting because it shows that Earth exists inside a natural shield of air and magnetic field, allowing us to experience the Sun's warmth without being exposed to its harsher emissions. The connection between flares and auroras can be especially calming to think about. While auroras are more strongly driven by solar wind disturbances and coronal mass ejections, flares are part of the Sun's overall magnetic behavior. Auroras themselves are a gentle outcome, turning invisible energy into soft curtains of light. This is a soothing reminder that solar activity can create beauty, not just scientific interest, and that the universe often expresses energy through calm, glowing displays. Solar flares also teach patience in how we understand natural systems. We do not predict them perfectly, but we can see patterns, monitor active regions, and learn from repeated observations. This slow learning process mirrors the Sun's own slow build-up and release of energy. It is a calm science built on watching, measuring, and understanding gradual change over time, rather than reacting to sudden drama. Perhaps the most restful truth is that after every flare, the Sun continues. Its core remains in steady fusion balance. Its light continues to travel outward in an unbroken stream. Its magnetic fields continue to shift slowly, preparing for future releases. Solar flares rise and fade like gentle pulses of brightness in a star that remains warm, stable, and constant. quietly holding its place at the center of the solar system while its magnetic atmosphere continues its slow and graceful motion. Solar flares become easier to rest with when you imagine them as a natural part of the sun's slow self-maintenance. The sun is always moving, always circulating plasma, always shaping and reshaping magnetic field lines. Over time, those magnetic lines can become stressed, storing energy like gentle tension held in a stretched band. A flare is the moment that tension is released, allowing the field to relax into a simpler configuration. It is the sun finding comfort again, returning its magnetic atmosphere to balance. A calm scientific detail is that flares often begin in regions where magnetic field lines are packed closely together and have opposite directions. In these boundary zones, the magnetic structure can become unstable in a very specific way, allowing reconnection to occur. Reconnection is not random motion. It is a process that follows the physics of plasma and magnetism, transforming a complex pattern into a smoother one. The energy released is simply the excess stored in the previous arrangement, and once released, the system becomes quieter. Solar flare light is often strongest in ultraviolet and X-ray wavelengths, because the heated plasma in the corona reaches very high temperatures. But this does not mean the sun is burning hotter in a permanent way. It means that a small region of plasma has been heated briefly by magnetic energy conversion. This is soothing because it keeps the event localized. The sun's overall brightness and stability remain steady, while the flare is a temporary highlight in the sun's outer atmosphere. When a flare occurs, it can cause a sudden brightening in the chromosphere, the layer just above the sun's visible surface. These brightenings often appear as ribbons that slowly shift position as the magnetic reconnection region evolves. The word ribbon itself feels gentle because it describes something soft and flowing. The ribbons trace where energy is being deposited, showing that flare activity is not a single flash, but a process that moves gradually across magnetic structure. After the flare's peak, the sun's atmosphere enters a long settling phase. Hot plasma trapped in coronal loops begins to cool, radiating energy away slowly. The loops may remain visible for hours, fading gradually as their temperature falls. This slow fading is one of the most sleep-friendly aspects of solar flares. It is a reminder that energy release is followed by calm restoration, and that the sun naturally returns to steady quiet after each burst. Some solar flares create radio bursts that can be detected on Earth. These radio signals come from electrons moving through the sun's magnetic environment and interacting with plasma waves. Radio bursts sound like noise in scientific terms, but in a calm perspective, they are simply another way the sun communicates its changes through the electromagnetic spectrum. They are signals, not alarms, carrying information outward into space. Solar flares can also trigger waves in the solar atmosphere that travel outward like ripples. These waves may move through the corona, guided by magnetic fields, and gradually fade as their energy disperses. The imagery of waves is especially soothing because it suggests smooth motion spreading through a medium rather than sharp disruption. The sun's atmosphere becomes like a glowing ocean, and the flare becomes a disturbance that turns into gentle ripples and then quiet again. One peaceful part of flare science is that many small flares happen frequently. These minor flares release small amounts of energy and may not be noticed outside scientific instruments. They are part of the sun's constant background adjustment, like tiny releases that keep the system from storing too much stress. This makes the sun feel less dramatic and more like a steady machine of balance, quietly correcting itself through many small steps. Earth's magnetic field helps protect us from the energetic particles that can be produced during strong solar events. While flare radiation reaches us quickly, most particles take longer and are guided by the solar wind. Earth's magnetosphere deflects many of these particles, channeling some toward the poles where they can create auroras. This is comforting because it shows a calm partnership between the sun and Earth, where energy flows outward and is gently redirected into safe, beautiful effects. Perhaps the most restful truth is that solar flares are temporary expressions of a star that is fundamentally steady. The sun has shone for billions of years and will continue shining for billions more. Its core fusion remains stable, and its overall output is consistent. Flares are surface-level adjustments in magnetism, brief brightenings that rise and fade, leaving the sun's atmosphere calm again, ready to continue its slow, graceful movement across time. Solar flares can feel deeply calming when you think of them as moments when the sun gently clears its own tension. The sun's magnetic field is always being shaped by motion, not motion that is rushed, but motion that is steady and constant. Plasma rises, falls, and drifts across the sun's surface, slowly twisting magnetic structures above active regions. The flare is the moment when those stress structures find a simpler configuration, releasing stored energy and returning the surrounding atmosphere to a quieter balance. A peaceful detail is that the sun's magnetic fields are anchored in the surface, especially around sunspots. Sunspots are darker because strong magnetism reduces the upward flow of heat, but they are still extremely hot by human standards. They act like calm magnetic roots, holding field lines in place while the plasma around them shifts slowly. When reconnection happens above these anchored regions, it is like the sun rearranging the curves of its own magnetism, allowing stress to dissolve into warmth and light. Solar flares often create a combination of light and heat that spreads outward through the sun's atmosphere. This energy does not travel randomly, it follows magnetic field lines, moving along loops that arch into the corona like soft, glowing bridges. These loops can brighten, fill with hot plasma, and then slowly fade as they cool. The gentle arc shapes and the slow cooling process make the flare feel less like an explosion and more like a temporary glow that settles back into quiet. The flare's brightest phase is usually short, but the calm part is what happens afterward. The sun's atmosphere enters a long cooling phase, where hot plasma gradually releases energy as radiation. In this decay phase, the flare is no longer rising, it is settling. Loops remain visible, soft and luminous, then slowly dim back into the sun's quiet background atmosphere. This long fade can last much longer than the initial burst, creating a natural rhythm of rise and return. Solar flares also highlight the way the sun communicates through different wavelengths of light. Much of the flare's energy is invisible to our eyes, appearing in ultraviolet and X-ray light. Instruments detect these changes as smooth curves of brightness rising and falling over time. It is soothing to remember that the sun's behavior can be measured as gentle waves in data, patterns of light changing gradually, reflecting physical processes that follow predictable laws. Some flares produce something called chromospheric evaporation, which sounds intense but is actually a simple process. Energy from the flare heats the lower atmosphere, and the heated material expands upward into coronal loops. This upward flow is guided and smooth, like warm air rising slowly, except it happens in plasma under magnetic control. The result is loops filling with hot material, brightening gradually before beginning their slow cooling. Solar flares may also produce subtle motions in the sun's atmosphere called oscillations. Magnetic loops can vibrate like softly plucked strings, sending waves along their lengths. These oscillations fade over time as energy spreads out. The idea of gentle vibrations in glowing loops adds a peaceful rhythm to flare behavior, reminding you that even energetic processes can take the form of waves and soft motions rather than harsh disruption. A comforting part of solar flare science is that the sun's activity follows a long magnetic cycle. Over roughly 11 years, solar activity rises and falls, changing the frequency of sunspots and flares. This means there are seasons of higher activity and seasons of quieter calm. The sun's rhythm is slow and predictable, which is soothing because it shows that the star at the center of our lives is governed by long-term patterns, not sudden stability. On Earth, the most visible connection to solar activity is often the aurora, those calm curtains of light near polar regions. While auroras are more strongly linked to solar wind changes and ejections, flares are part of the same magnetic story. The comforting part is that solar energy does not always appear as disruption. Sometimes it becomes beauty, turning invisible particles into soft glowing colour in the sky, reminding us that energy can express itself in gentle forms. Perhaps the most restful truth is that solar flares are small compared to the sun's overall stability. The sun shines steadily because fusion in its core changes extremely slowly. Flares occur in the atmosphere, localized and brief, like small adjustments on a vast surface. After each flare, the magnetic field relaxes, the loops cool, and the sun continues its quiet glow, patient and consistent, holding its place in the solar system with calm permanence. Solar flares feel most soothing when you imagine them as the sun's way of gently reorganizing itself. The sun's atmosphere is filled with magnetic structures that are constantly being shaped by slow motion below the surface. Over time, these structures can store energy, like a calm tension held in invisible curves. A flare is the moment when that tension releases, allowing magnetic fields to settle into a simpler, quieter arrangement, and afterward the sun returns to its steady, familiar glow. A calm scientific truth is that flares often happen near magnetic boundaries, where different magnetic regions press close together. In these areas, the field can become complex and stressed, and reconnection can occur. Reconnection may sound sharp, but the purpose of the process is gentle. It is the sun finding a more comfortable magnetic shape. Energy is released because the old arrangement held more tension than the new one, so the flare becomes a natural step toward balance rather than a sign of disorder. During a flare, plasma in the corona can heat up dramatically, but the corona itself is thin, spacious and delicate. It is not dense like a planet's atmosphere. It is more like a faint glowing mist guided by magnetic lines. This makes the flare feel like a brightening in a wide open space where energy can spread without being trapped. The sun's atmosphere becomes luminous and warm in localized regions, then slowly fades back to calm. The loops that brighten during flares are among the most peaceful structures in solar physics. They arc smoothly, forming glowing bridges of hot plasma that trace the invisible magnetic field. As the flare unfolds, these loops can fill with heated material, shining brightly for a while, then cooling and dimming gradually. This slow dimming is soothing because it shows the sun naturally returning to a quieter state, letting the flare become part of a gentle cycle of brightening and settling. Solar flares can produce bursts of X-ray and ultraviolet light that travel outward at the speed of light. This radiation reaches Earth quickly, about 8 minutes, but Earth's atmosphere absorbs most of it, preventing it from reaching the ground. The calmness here is reassurance. Solar flare radiation is part of space weather, but our world is protected naturally, allowing the sun's changes to remain mostly distant and gentle in their effect on daily life. Sometimes a flare produces radio emissions as well. These radio waves come from charged particles moving through plasma in the sun's atmosphere. To instruments, they appear as brief radio bursts, another quiet signal that the sun has adjusted its magnetic structure. This reminds us that the sun communicates through light of many kinds, offering messages across the electromagnetic spectrum that are silent, steady and measurable. A soothing detail is that the flare's timeline often includes a long cooling phase, where energy gradually disperses. After the peak, the atmosphere does not stay intense, it settles. Heated plasma radiates energy away, loops fade gently, and the brightness returns to normal levels. This slow decline is a natural calming rhythm, like the way warmth lingers softly after a brief bright moment then fades into quiet. Solar flares help scientists study plasma physics, magnetism and energy transfer, but for a listener resting, it can be comforting to know that flare behavior follows consistent physical laws. Magnetism stores energy. Reconnection releases it. Plasma responds by heating and flowing along field lines. Light is emitted. Cooling follows. This orderly sequence makes flares feel predictable, like a pattern that repeats gently whenever conditions align. The sun's magnetic cycle gives flares a seasonal quality. In active years, sunspots become more common and flares occur more often. In quiet years, the sun appears calmer, with fewer active regions. This rhythm is comforting because it means the sun is not behaving randomly. It moves through long patterns that rise and fall slowly like a tide, showing that solar activity has structure and timing. Perhaps the most restful thought is that solar flares are not separate from the sun's calm existence. They are small local adjustments in a star that remains stable and steady over billions of years. The sun continues shining, radiating warmth and light in an unbroken stream, while flares come and go as brief magnetic releases. Each flare brightens, then fades, leaving the sun ready to continue its slow, patient motion, glowing quietly at the center of our solar system. Solar flares can feel peaceful when you picture them as the sun quietly smoothing out its own magnetic patterns. The sun is always moving, but it moves in slow, continuous flows rather than sudden jolts. Beneath the surface, hot plasma rises and sinks, and on the surface magnetic regions drift and shift. Over time, these motions can twist magnetic field lines above active regions, storing energy gently like tension held in a soft spring. A flare is the moment that spring releases, returning the magnetic structure to a calmer shape. One calming detail is that the sun's magnetic field is not fixed. It is alive and changing, shaped by the star's rotation and internal motion. This means solar flares are not signs of damage. They are signs of motion and adjustment, a natural outcome of a magnetic star maintaining itself. The sun's behavior is not random. It is governed by clear physical laws that unfold consistently, which makes flares feel like predictable expressions of a steady system rather than unpredictable surprises. Solar flares often brighten coronal loops, those gentle arches of plasma suspended in the sun's corona. These loops trace magnetic field lines, and when energy is released, hot plasma flows into them, causing them to glow intensely in ultraviolet and X-ray light. The shape of these loops is soothing because it is smooth and curved, like softly lit bridges stretching above the sun's surface. As the flare fades, the loops cool slowly and dim, returning to the corona's calmer background glow. The process of cooling after a flare is one of the most restful aspects of flare science. After the peak, heated plasma begins releasing energy through radiation. It may also conduct heat down toward lower layers. Over time, temperatures drop and brightness decreases. This is a natural settling phase, like a warm room slowly cooling after a brief burst of heat. The sun does not hold onto the flare's intensity. It releases energy, then relaxes, leaving behind a quieter atmosphere. Solar flares often produce bright ribbons on the sun's surface in the chromosphere. These ribbons form where energy is deposited along magnetic field lines, heating denser plasma below. The ribbons can gradually spread apart as reconnection progresses, tracing the changing magnetic structure. The motion of these ribbons is smooth and unfolding, emphasizing that flares are processes with a timeline, not just instant flashes. A gentle truth about solar flares is that most of them are small. The sun produces many flares that release relatively modest energy, sometimes too small to be noticed outside scientific monitoring. These small flares act like tiny pressure releases, helping the sun's magnetic field stay balanced. This makes the sun feel even calmer, because it suggests the star often releases tension in small, frequent ways rather than building toward constant extremes. Solar flare energy can be released as electromagnetic radiation, and that radiation travels outward through the solar system. In space, this light is simply part of the ongoing stream of signals moving through darkness. It spreads and fades with distance, becoming part of the wider environment of the solar system. This is soothing because it shows that energy does not remain concentrated. It naturally disperses, blending into the vast calm of space. Earth's atmosphere and magnetic field help make solar flares feel distant and safe. While flare radiation can cause subtle changes in the ionosphere, Earth's surface remains protected. Many effects are quiet and unnoticed. This is comforting because it shows that we live under a natural shield, able to experience the sun's warmth without being exposed directly to its higher energy emissions. Solar flares also connect to the slow rhythm of the solar cycle. As the sun moves from minimum to maximum, its magnetic field becomes more complex and sunspots appear more frequently. Flares become more common during active phases, then activity gradually declines again. This long wave of change is soothing because it gives the sun a sense of seasons, a slow pattern unfolding over years rather than sudden shifts. Perhaps the most restful thought is that solar flares are a small part of the sun's vast existence. The sun has shone for billions of years and will shine for billions more. Its core fusion remains stable, powering steady light. Flares are surface-level adjustments, brief moments of release in a magnetic atmosphere that continuously reshapes itself. They brighten, they fade, and the sun continues, glowing calmly, holding its steady place at the center of our solar system, while its magnetism moves slowly and quietly like an endless rhythm. Solar flares can feel calm when you think of them as the sun's gentle way of returning to balance. The sun's outer layers are filled with magnetic structures that grow slowly over time, shaped by the steady motion of plasma across the surface. These magnetic structures can store energy in a quiet, patient way, like tension held in a softly twisted ribbon. When the flare occurs, that stored energy is released, and the magnetic field settles into a simpler pattern, leaving the atmosphere calmer than before. A peaceful detail is that solar flares most often happen around active regions where sunspots gather. Sunspots are not signs of harm. They are stable magnetic regions, slightly cooler than their surroundings, that appear dark by comparison. They can last for days or weeks, drifting slowly across the sun's face. Above them, magnetic loops rise into the corona, forming elegant arches that hold hot plasma suspended in curved light. When a flare happens, it often brightens this existing structure, revealing it more clearly rather than creating something chaotic. The corona itself is a place of quiet contradiction. It is extremely hot but also extremely thin. The plasma there is sparse, almost like a glowing fog. This thinness makes the flare feel less harsh, because energy can spread quickly through open space. The flare becomes a localized brightening in a vast atmosphere, not a dense blast. The sun's outer layers glow, expand, and then settle again, like light slowly moving through mist. During the flare, magnetic reconnection can change the arrangement of field lines, releasing energy in the process. The word reconnection can sound sharp, but the outcome is gentle. A tangled magnetic pattern becomes smoother. Energy that was stored becomes heat and light, and then the system moves toward a calmer configuration. It is like the sun untangling itself, choosing simplicity over tension, letting excess energy go in order to return to steadiness. As flare energy spreads, hot plasma often fills coronal loops, making them shine brightly in ultraviolet and X-ray light. These glowing loops can remain visible long after the flare peak, slowly cooling and fading. The cooling process is one of the most restful parts of flare behavior. Brightness softens gradually, and the sun's atmosphere returns to its quiet background glow without hurry, as if the flare's warmth is gently dissolving into the larger calm. Solar flares often create bright ribbons in the chromosphere, the layer below the corona. These ribbons form where energy is deposited as particles travel downward along magnetic field lines. Over time, the ribbons can separate slowly, tracing how the reconnection region evolves. This movement is smooth and gradual, giving the flare a sense of slow unfolding. Even when energy is released quickly, the visible changes on the sun often have a calm, continuous motion. A soothing truth is that solar flares occur across a wide range of sizes. Many flares are small and modest, detected only by sensitive instruments. These frequent small flares act like quiet releases that help the sun maintain balance. They are like tiny adjustments happening constantly in the background, keeping magnetic stress from building too much. This makes the sun feel like a steady system that naturally regulates itself through many gentle steps. The energy that leaves the sun during a flare often travels outward as light, and that light becomes part of the solar system's continuous stream of radiation. It spreads through space without resistance, fading with distance, becoming part of the larger cosmic quiet. This is calming because it shows that energy does not stay concentrated. It disperses naturally into the open stillness of space. Earth's atmosphere protects us from much of the flare's high-energy radiation. While the upper atmosphere may respond with subtle changes, the surface remains calm and undisturbed. This quiet protection is comforting because it shows that the Earth and Sun interact in a gentle way most of the time. The Sun can shift and release energy, and Earth can remain stable, wrapped in its own atmosphere and magnetic field. Perhaps the most restful thought is that solar flares do not change the Sun's steady nature. The Sun's core fusion continues quietly, producing a stable stream of light that reaches Earth day after day. Flares are brief magnetic adjustments in the atmosphere, bright moments that rise and fade. After the flare, loops cool, ribbons dim, and the Sun continues its slow rhythm, shining calmly at the center of our solar system, always moving, always balancing, and always returning to quiet. Solar flares can feel most restful when you picture them as small, natural moments of the Sun releasing what it no longer needs to hold. The Sun's atmosphere is threaded with magnetic fields that are constantly being shaped by slow plasma motion beneath and across the surface. These fields can become stressed, not through sudden force, but through steady twisting that builds gently over time. A flare is the moment when the magnetic pattern rearranges itself into something simpler, letting stored energy flow out as light and heat, and then allowing the atmosphere to settle back into calm stability. A quiet scientific detail is that the Sun's surface is not still. It is always moving with convection, like a slow boiling pattern of rising hot material and sinking cooler material. These movements are continuous and steady, and they carry magnetic fields along with them. Over hours and days, magnetic regions can drift, rotate, and shift position. This slow choreography creates the conditions for flare energy to build without hurry, giving the Sun's activity a gentle sense of preparation rather than sudden eruption. When a flare begins, it often does so high in the corona, where plasma density is low and space is wide. This makes the flare feel less intense than the word suggests. Even when plasma becomes extremely hot, the corona remains thin and open, allowing energy to spread without building heavy pressure. In that environment, a solar flare becomes a brightening in a delicate layer, like a glowing wave passing through a transparent mist. One of the most soothing images in flare science is the way hot plasma fills coronal loops. These loops trace magnetic field lines, forming graceful arches above the Sun's surface. During a flare, loops brighten as they fill with hot material, then slowly fade as they cool. This slow cooling can take a long time, creating a gentle afterglow that lingers well beyond the flare's brightest moment. The Sun does not snap back instantly. It eases back into quiet, letting the warmth fade naturally. Solar flare ribbons in the chromosphere are another calm feature when seen through a slow lens. They form where flare energy is deposited at the base of magnetic loops. As reconnection continues, these ribbons can gradually separate and spread. Their motion is smooth and measured, like two bands of light drifting apart on a surface. This reminds you that a flare is not just a flash. It is a process that unfolds, shifts, and settles over time. A calming truth is that many flares are confined, releasing energy without launching massive clouds of material outward. These confined flares brighten the Sun's atmosphere briefly, then fade as the magnetic field relaxes. The Sun often keeps its energy release contained within its own structure, like a quiet internal adjustment. Even when the Sun does eject plasma, the movement is guided by magnetism and travels through space, slowly compared to light, emphasizing the overall patient pace of solar events. Solar flares produce light across the electromagnetic spectrum, including ultraviolet and X-rays. To our eyes, the Sun looks steady, but instruments see these invisible brightenings as flare signatures. This is soothing because it shows that the sun's changes can be detected as smooth curves of brightness rising and falling, like gentle waves in a quiet graph. The flare's story can be traced calmly through data, revealing a star that follows laws and patterns rather than random outbursts. Earth is naturally protected from much of the high-energy radiation produced by flares. The atmosphere absorbs most ultraviolet and X-rays high above the surface, keeping the ground calm and unchanged. The ionosphere may respond with subtle shifts that affect radio waves, but these effects are usually brief and quiet. This makes the relationship between the Sun and Earth feel safe, like a distant connection where the Sun expresses itself while Earth remains sheltered. The Sun's magnetic cycle adds a slow rhythm to flare frequency. During active phases, sunspots and flares become more common. During quieter phases, the Sun's surface appears smoother and calmer. This long cycle, lasting about 11 years, is comforting because it gives solar activity a seasonal pattern. It rises, peaks, and declines again, like a tide of magnetism moving slowly through time. Perhaps the most restful thought is that solar flares are small compared to the Sun's overall existence. The Sun has been shining steadily for billions of years, held in balance by gravity and pressure, powered by slow fusion deep inside. Flares are atmospheric moments, brief releases of stored magnetic energy. They brighten, they fade, and the Sun continues, glowing calmly at the center of the solar system, always shifting gently, always returning to quiet, and always shining with steady patience. Solar flares become calming when you imagine them as part of the Sun's steady self-regulation, like a natural release that keeps the system comfortable. The Sun's outer atmosphere is filled with magnetic loops and arches, built slowly as plasma moves across the surface and twists magnetic fields over time. These magnetic structures can store energy quietly, like tension held in invisible curves. A flare happens when that stored energy is released through a rearrangement of magnetic field lines, allowing the Sun's atmosphere to relax into a gentler shape and return to quiet stability. A soothing truth is that solar flares are often preceded by long periods of calm magnetic buildup. The Sun does not snap suddenly into flare activity without preparation. Magnetic regions drift and evolve slowly, sometimes over days, building complexity as plasma motions gently shear and twist field lines. The flare is simply the point where that complexity reaches a moment of release, like a slow knot being undone in one smooth motion, leaving the system simpler than before. The Sun's corona is where the flare often shows its most graceful forms. The corona is extremely hot, but thin and open, with plasma guided almost entirely by magnetism. When a flare occurs, coronal loops brighten as hot plasma fills them, tracing the magnetic field in glowing arcs. These arcs are smooth and calming to picture, like bridges of light hanging quietly above the surface. They remind us that energy release does not always mean disorder. It can reveal structure, showing how magnetism shapes the Sun in elegant geometry. After the flare's peak, the Sun enters a long settling phase where heated plasma cools gradually. This cooling happens through radiation and conduction, and the brightness in loops slowly fades back into the background corona. The calmness of this phase is that it takes time. The Sun does not rush back to quiet. It eases back, letting energy disperse naturally into space and into surrounding plasma, like warmth fading gently from a surface over minutes or hours. Solar flare ribbons on the Sun's surface are another gentle phenomenon when seen through a peaceful lens. They form where energy flows down magnetic field lines into denser layers of the atmosphere. These ribbons often appear in pairs and can slowly move apart as reconnection progresses. The movement is smooth and steady, creating the feeling of light unfolding gradually rather than flashing harshly. Even in its brightest moments, the flare can be understood as a process, not a single instant. Not all flares produce large ejections of material. Many remain confined, releasing energy primarily as light and heat within the solar atmosphere. This is comforting because it means much of the Sun's activity stays gentle and self-contained. the sun can brighten and adjust its magnetism without sending a large disturbance outward, like a quiet internal shift that resolves tension without creating extra motion beyond its own atmosphere. Solar flares are part of a star that follows long-term rhythms. The sun's magnetic cycle rises and falls over about 11 years, bringing periods of more frequent sunspots and flares and periods of quieter calm. This rhythm gives solar activity a seasonal feeling, like a slow wave moving through time. It is reassuring because it means flare activity is connected to predictable patterns, not sudden unpredictability. The energy from a flare travels outward as light across the electromagnetic spectrum. Ultraviolet and X-rays reach Earth quickly, but Earth's atmosphere absorbs most of this high-energy radiation high above the surface. The ground remains calm and unchanged. This protective filtering is soothing because it shows how the sun and Earth interact gently most of the time, with Earth's atmosphere acting like a quiet shield that allows warmth and visible light through while absorbing harsher energy. Solar flares also help explain why auroras can appear, those soft curtains of light near Earth's poles. While auroras are often linked more strongly to coronal mass ejections and solar wind shifts, flares are part of the sun's broader magnetic story. The calming part is the transformation. Invisible energy becomes visible beauty, turning particles into glowing colour that moves gently across the night sky, like a quiet reminder of the sun's connection to our planet. Perhaps the most restful thought is that solar flares do not change the sun's steady nature. The sun remains stable, balanced by gravity and pressure, powered by slow fusion deep in its core. Flares are surface-level adjustments, brief releases of magnetic energy that brighten and fade. After each one, the corona cools, the loops dim, and the sun continues its calm glow, patiently repeating its cycles of motion, balance, and quiet light at the center of our solar system. Solar flares can feel peaceful when you view them as moments of natural release in a star that is otherwise steady and calm. The sun's magnetic field is always being shaped by slow motion in plasma, like invisible lines gently stretched and twisted over time. These magnetic lines can hold energy quietly, building it without urgency. When a solar flare occurs, it is not an accident or a breakdown. It is the sun letting go of stored magnetic tension, rearranging its field into a simpler pattern and returning the surrounding atmosphere to a more relaxed state. A soothing detail is that the sun's surface moves in slow, consistent patterns that create flare conditions gradually. Convection rises and falls like quiet bubbling, carrying magnetic fields along. Larger flows drift across the surface, slowly moving sunspot groups and magnetic regions. Over hours and days, these motions can shear magnetic field lines, increasing complexity above active regions. This means a flare is often the result of long preparation, like a calm build-up that reaches a natural point of release. The corona, where flares often reveal their most graceful structures, is a region of thin, luminous plasma shaped by magnetic fields. Even though the corona can reach extreme temperatures, it is so sparse that it feels delicate rather than overwhelming. When flare energy is released, coronal loops brighten, filled with hot plasma that follows curved magnetic paths. These loops appear like glowing arches suspended in space, and their smooth shapes help the flare feel like an organized brightening rather than chaotic motion. After the flare reaches its brightest moment, the most calming part begins, the slow settling. The heated plasma in flare loops begins to cool, radiating energy away gradually. This cooling can take much longer than the flare's peak, leaving a gentle afterglow in the corona. The sun's atmosphere does not remain in an intense state. It naturally relaxes, fading back into quiet brightness as energy disperses into space, like warmth slowly leaving a surface over time. Solar flare ribbons, bright features seen in the chromosphere, form where energy is deposited at the base of magnetic loops. These ribbons can appear in pairs and slowly drift apart as the flare develops. Their movement is smooth and steady, tracing the evolution of magnetic reconnection. This slow motion makes the flare feel like a gentle unfolding, as if light is gradually painting a pattern across the sun's surface rather than flashing sharply. Many flares remain confined, releasing energy without launching large amounts of plasma outward. This is comforting because it shows that much of the sun's activity is self-contained, like an internal adjustment that resolves tension without expanding into a larger disturbance. Even when material is ejected, it travels through space slowly compared to light, taking days to reach Earth, and the vastness of space softens its impact by spreading the energy outward. Solar flare light travels outward as part of the sun's constant stream of radiation. During a flare, the sun briefly brightens in ultraviolet and X-rays, wavelengths invisible to human eyes but measurable by instruments. This radiation reaches Earth quickly, yet Earth's atmosphere absorbs most of it, keeping the surface calm and unchanged. The flare's energy becomes a quiet interaction high above us, a subtle shift in the upper atmosphere rather than something that disrupts life below. The sun's magnetic cycle provides a slow rhythm behind flare frequency, rising and falling over about 11 years. During active phases, sunspots become more common and flares happen more often. During quieter phases, the sun appears smoother, with fewer active regions. This long rhythm is soothing because it makes solar activity feel seasonal and predictable, like a tide of magnetism that comes and goes gently over years. Solar flares also remind us that our sun is a stable star compared to many others. Some young stars produce flares far stronger and more frequent than our sun ever does. In this broader stellar context, our sun's flare activity feels modest, an occasional magnetic release rather than constant intensity. This is comforting because it places us in a solar system centered on a star that remains steady, balanced, and consistent through long stretches of time. Perhaps the most restful thought is that solar flares do not change the sun's overall character. The sun continues shining with calm consistency, powered by fusion in its core, a process that evolves slowly over billions of years. Flares are brief atmospheric events, small adjustments in a vast magnetic system. They brighten, they fade, and the sun returns to quiet glow, continuing its slow, patient rhythm at the center of our solar system as the days and years pass gently beneath its steady light. Solar flares can feel calm when you understand them as the sun's way of gently releasing what it has been holding. The sun's magnetic field is always present, weaving through hot plasma like invisible architecture. Over time, the motion of plasma near the surface can twist and stretch magnetic field lines, storing energy in a quiet, patient way. A flare is the moment when those stressed magnetic structures reorganize into a simpler shape, releasing the excess energy as light and heat, and then allowing the atmosphere to settle back into a more relaxed state. A peaceful detail is that solar flares are usually rooted in active regions where magnetic complexity grows slowly. These regions often contain sunspots, darker patches that appear because strong magnetic fields reduce the normal upward flow of heat. Sunspots drift across the sun's face with the star's rotation, lasting for days or weeks. They act like stable magnetic anchors, holding the ends of coronal loops in place while plasma motions above and below them gently build the conditions for a flare. The sun's corona is where solar flares often show their most graceful form. The corona is extremely hot, but it is also very thin, meaning it has low density. This makes the flare feel less heavy and more luminous, like a brightening inside a delicate atmosphere. When a flare releases energy, coronal loops glow more intensely as hot plasma fills them. These loops appear as smooth arcs of light, revealing the sun's magnetic structure as something orderly, curved, and calm in shape. After the flare's peak brightness, the sun's atmosphere begins a long and gentle cooling phase. Hot plasma trapped in loops radiates energy away and gradually returns to lower temperatures. The loops slowly fade, becoming dimmer and quieter until they blend back into the background corona. This fading is one of the most soothing aspects of flare behavior, because it shows that energy release naturally leads into calm restoration, and that the sun never stays in an intense state for long. Solar flares can create bright ribbons in the chromosphere, where energy is deposited along magnetic field lines into denser atmospheric layers. These ribbons often appear in pairs and slowly shift position over time as reconnection continues. Their motion is gradual, like soft bands of light drifting apart. This slow unfolding makes the flare feel like a process you can follow calmly, rather than a sudden event that vanishes instantly. Not all solar flares produce large ejections of solar material. Many remain confined, releasing their energy mainly as radiation and heating within the solar atmosphere. This is comforting because it means much of the sun's activity stays contained, like a quiet internal adjustment. Even when a coronal mass ejection happens, it moves through space over hours and days, giving the event a slower pace than the word eruption might suggest. Solar flare radiation travels outward at the speed of light, but most of it is absorbed by Earth's atmosphere high above the ground. The surface remains calm, protected by layers of air and by Earth's magnetic field. The effects that do occur are often subtle, such as brief ionospheric changes that can influence radio communication. This natural protection is soothing because it reminds us that Earth and Sun interact in a stable way, with systems in place that soften the Sun's more energetic expressions. The Sun's flare activity rises and falls with its magnetic cycle, which lasts about 11 years. During active periods, flares become more frequent. During quiet periods, they become less common. This rhythm gives flare behavior a seasonal feeling, like a slow wave that builds and fades over years. It is calming because it shows that the sun follows long patterns rather than sudden unpredictability, moving through changes patiently. Solar flares also help scientists understand the physics of plasma and magnetism, but in a restful view, it is comforting that these events follow consistent laws. Magnetic energy builds through slow motion. Reconnection releases it. Plasma heats, flows along loops, and cools. Light rises, peaks, and fades. The sequence is orderly, like a gentle natural cycle repeating whenever conditions align, not like a random burst without meaning. Perhaps the most restful truth is that solar flares do not disturb the sun's steady nature. The sun continues shining calmly, powered by fusion in its core that changes extremely slowly over billions of years. Flares are brief atmospheric adjustments, localized and temporary. They brighten the corona for a while, then fade. The loops cool and settle, and the sun remains the same steady star, quietly glowing at the center of the solar system, always moving gently, always balancing its magnetism, and always returning to calm. Solar flares can feel peaceful when you imagine them as the sun's gentle way of loosening its grip on stored magnetic tension. The sun is not a quiet, frozen object. It is a living sphere of plasma, always flowing, always circulating. Within that flow, magnetic field lines are carried, stretched, and shaped over time. They can become twisted and stressed, quietly holding energy in their structure. A flare is the moment the sun releases that stored energy through magnetic rearrangement, letting the atmosphere relax into a calmer shape and returning the system to balance. A soothing detail is that solar flare energy builds slowly before it is released. Magnetic complexity does not appear suddenly. It grows as sunspot groups drift across the surface and as plasma motion gently shears magnetic field lines. Over hours or days, the energy accumulates like pressure held softly inside an invisible container. This slow build-up makes the flare feel less like a surprise and more like the natural result of gradual change reaching a point where release becomes the simplest path. When a flare begins, much of the key action often happens in the corona, the sun's outer atmosphere. The corona is extremely hot, but it is also thin and spacious, with low-density plasma guided by magnetic fields. This creates a calming environment because it allows energy to spread quickly without creating harsh, shock-like pressure in dense material. The flare becomes a brightening in a delicate, wide layer, like light moving through a thin mist rather than an explosion in a crowded space. Coronal loops are among the most soothing structures connected to solar flares. These loops form where magnetic field lines arch out of the surface and return again, creating smooth curves that hold plasma in place. During a flare, these loops often brighten as hot plasma fills them. They glow strongly for a time, tracing the magnetic architecture in gentle arcs, then slowly fade as the plasma cools. The quiet fading is one of the most comforting parts of flare behavior, showing the sun naturally settling after releasing energy. In the chromosphere, flare ribbons can appear as bright, elongated regions where energy is deposited at the base of magnetic loops. These ribbons often appear in pairs and can slowly move apart over time as reconnection continues. Their motion is gradual and flowing, like soft bands of light shifting across the surface. The slow evolution reminds you that flares are not just single flashes, they are unfolding processes with a beginning, a peak, and a calm return. Many solar flares confined, meaning they release energy without launching a large cloud of plasma outward. This is comforting because it shows that a flare can be mostly an internal atmospheric event, a bright magnetic adjustment that remains contained within the sun's own environment. Even when a coronal mass ejection does occur, it travels through space over long timescales, giving the event a slower, more measured pace as it moves outward into the solar system. The sun's flare radiation, including ultraviolet and X-rays, travels outward at the speed of light. It reaches Earth quickly, but Earth's atmosphere absorbs most of this high-energy radiation, keeping the surface calm. The upper atmosphere may respond gently with subtle changes in ionization, but the world below remains steady. This quiet protection is soothing because it means the sun can express its magnetic energy, while Earth remains sheltered within its natural layers. Solar flare activity is also guided by the sun's long-term magnetic cycle. Over about 11 years, the sun's activity rises and falls, changing the frequency of sunspots and flares. During solar maximum, flares become more common. During solar minimum, the sun becomes quieter again. This cycle adds a comforting rhythm to solar behavior, like seasons of magnetism unfolding slowly, reminding you that the sun's activity has patterns and timing rather than randomness. Another restful truth is that solar flares are small compared to the sun's overall stability. The sun shines steadily because fusion in its core changes slowly, balanced by gravity and pressure. The sun's total energy output remains nearly constant despite flares. A flare is like a bright spark on the surface of something enormous and steady, a localized event that rises and fades without changing the sun's long-term calm existence. Perhaps the most soothing thought is that solar flares always pass. They brighten, release their energy, then fade into quiet. The sun's atmosphere cools, loops settle, and the star returns to its steady glow. Even though flares are energetic, they are part of a calm cycle of tension and release, showing a universe where energy builds gently, is released when needed, and then disperses naturally into space, leaving behind stillness once again. As this quiet journey through solar flares continues to settle gently in your mind, there is nothing you need to hold on to, and nothing you need to follow. The sun can remain warm and steady without needing your attention. Its light will keep moving outward into space, calm and consistent, while its magnetic fields continue their slow, patient motion beneath the surface. You may notice your thoughts becoming softer now, less defined, like faint light spreading out through a wide sky. That is perfectly natural. Just as the sun releases energy and then returns to balance, your mind does not need to stay tense or focused. Everything can loosen gently, and everything can remain simple. Let your breathing stay easy and unforced. Let your body rest exactly where it is. Imagine the sun as a distant, steady presence glowing quietly at the center of the solar system. Even its moments of brightness fade into calm again. Loops of light dim slowly. The atmosphere settles. The rhythm continues without hurry. Solar flares remind us that release is part of stability. Energy can rise, shift, and move outward, and then the system becomes calm again. Nothing needs to stay intense. Nothing needs to stay sharp. Even in the most powerful star nearby, balance always returns. guided by the same gentle laws that keep everything steady. Thank you for spending this time with the Sleepy Scientist. Whenever the world feels loud or your thoughts feel heavy, you're always welcome to return. The universe will still be here, moving slowly, glowing softly, and unfolding in its calm way. For now, allow the quiet to remain. Let the warmth fade into comfort. Let the light become gentle, and let whatever comes next arrive naturally.